Distinguished mathematicians, coming to you with another video. This is our last activity of this mathematics gymnastics. And then we have the homework. Yes, we do. All right. Factoring linear expressions. So you can use the distributive property to expand all expressions, as you did in the previous activity, and to factor linear expressions as Megan did. Consider the expression 7 times 26 plus 7 times 14. Since both 26 and 14 are being multiplied by the same number, 7, the distributive property says that you can add 26 and 14 together first. Then you can multiply their sum by 7 just once. So as you can see here, we added 26 plus 14, and then we put the coefficient or the 7 on the outside. So you can do that as well. You can add those two numbers as long as the two coefficients are the same number. So you have factored the original expression. The number 7 is the common factor of both 26 and 14, the 7 times 26 and the 7 times 14. Number 1, we're going to factor each expression using the distributive property. So if we use the distributive property, we have the same coefficient 4 and 4, which we can put on the outside, and we are subtracting these two numbers. So 33 minus 28. We have just factored each expression. Do the same for B. I can't wait to see what you come up with. The distributive property can also be used to factor algebraic expressions. For example, the expression 3x plus 15 can be written as 3x plus 3 times 5, or 3 times x plus 5. The factor 3 is the greatest common factor to both terms. When factoring algebraic expressions, you can factor out the greatest common factor from all the terms. So they gave us a worked example, but we're going to skip that. We're going to get right to it. I'm fixing to show you. So we're going to rewrite each expression by factoring out the greatest common factor. So what I like to do is take the smallest number first. That's not necessarily the best way, but it's the easiest way first. Or I can use my multiplication sheet, which is what I like to do. So I'm looking in the row. Since I see 7 and 14 together. So that means that I have to figure out how many 7s can go into the x, and then I have to figure out how many 14s. So when I look here, 7 goes into 7 one time. So I can take out 7, and I'm just going to rewrite x because I only need one of them. I don't need 2 x's. I don't need 3 x's. I just need one of them because 7 goes into 7 one time. So then I'm going to add. I'm going to figure out how many times 14 goes into 7. That goes in there 2 times. So that's how I factor. 7 times x. If I rewrite it and redo it, 7 times x is 7x. 7 times 2 is 14. So let's try another example. So I'm looking at 9 and 27. So I'm looking on my multiplication sheet. And another way to do it is just list your multiples. That's what the multiplication chart does. It lists your multiples for you. So you don't have to. And on start, again, you can create this. I can't create this for you, but we can practice. We're going to practice a lot in class doing it. Even for those of you that are star multipliers, star dividers, nobody's perfect because that star test is 48 questions and you're going to get tired and your eyes going to start crossing, honey. So you might want to have your backup multiplication chart just in case that happens. So I'm looking on this list. I'm looking for 9 and 27. I see 9 and 27 in the same row, and I see 9 is 1 time and 27 is 3 times. Now notice they have to be in the same row. 9 can't be way over here and 27 can't be over here. It has to be in the same row with each other. So I see 9 at 1, 27 at 3. So let's come back over here. So if I take out 9, I'm only going to need one of the x's. And if I take out 9 here, 27 turns into 3 because 9 times 3 is 27. And that's how you factor. All right, I want you to practice with C, D, E, and F. And for example, with D, you won't find 8 and 28 in the same row, but you might find, well, you will, but you might not find them all the time in like row 8 because 28 is not a multiple of 8. So you might have to go to a multiple of 8, which is 4 or 2, to see if you can find these numbers in those rows as well. So I'm just going to give you that hint. See if you got it. You can do it. C, D, E, and F. Awesome. Let's skip down here. Often, especially in future math courses, you will need to factor out the coefficient of the variable, but so that the variable has a coefficient of 1. Rewrite each expression by factoring out the coefficient of the variable. So down here, so this one, we're not going to have a perfect number. They want you to practice. You don't have to do this, but they just want you to practice so that the variable will always be 1. So if I take out 10, which is next to the variable, it makes it 1. So now you have to figure out, well, if I took out 10, then what is 45 divided by 10? Well, 45 divided by 10 is 4.5. So now you have a decimal version of that. So they just want you to practice doing that. Let me practice doing one more for you. The -2 is by the x, but I want the x by itself. I want it to be 1x. So I take out the -2. So now I have to do 3 divided by -2 to figure out what this number is. And 3 divided by -2 is really just, it's 3/2. You can leave it like that as well. And then the negative times a positive is a negative. You can leave it like that, or you can divide 3 divided by -2, which is 1.5. But I would suggest leaving it as a fraction. Just like I could have took the 45 and divided it by 10. So I could have just left it as x minus 45 divided by 10. And then I could have simplified 45 over 10, which would have brought it down to 9/2. 9 divided by 2, which is also 4.5. So either you can leave it as a fraction and then simplify your fraction, which should be probably the easiest version for most of you, or you can just go ahead and divide it if you have a calculator, whichever one works best for you. So you have C and D. Try it and we'll go over it. Number 4. We are going to rewrite each expression by factoring out the greatest common factor. So, and these are going to be a little bit harder because they're decimals, but don't fret, you can do it. So when doing the greatest common factor, again, I like to look at my paper, especially if it's whole numbers, and find the row with, like this one has 16 and 24. I see 16 and 24 here. I also see 16 and 24 here. So I want to figure out the smallest number. I'm going to use the 8, or the greatest common factor, which is 8. 4 is a smaller number than 8. I'm so sorry, you can't see me. 4 is a smaller number than 8. Even though the 16 and the 24 is in the 4, we want the greatest common factor. So you're looking for these two numbers in the largest number you see up here. And I see that at 16 and 24 under 8. And 16 has a 2 and 24 has a 3. So I'm going to take out 8 because that's my greatest common factor. My 24, I saw it at my 3. So -3x. And then my 16, I saw that at 2. So that's how I'm going to do it. I'm going to use 8 as my greatest common factor. I see 8 at 16 and 24, which is here. 16 and 24. I see them at the number 2. 16 is at the number 2. And 24 is at the number 3. But I cannot forget about my x, and I can't forget about my negative. B might be a little hard. Before you try B, go through and try C, D, and E first. If you got C, D, or E, go back to B. If you don't have C, D, and E, don't worry about B. We will figure out decimals later. You can also turn those decimals into whole numbers. I learned that if you move the decimal over once, you can move it over again. So that's 44 and then 12.1. So you can do it like that. That's just a hint. If you got it, you got it. If not, I got you. We'll go over it. All right, and then number 5. This is just going back to taking that x and evaluating the expression. So you're gonna take the x and substitute, and our x in this problem is 2.5. Remember, you can change that 2.5 into a decimal if you need to, or keep it as a fraction if you're good in fractions. But whatever you do, substitute it in. What do I mean by that? Replace the x with its number, excuse me, and then solve it. And you're gonna do that for A and B. See, I'm not really worried about. I just want to know, can you do that? All right. Can't wait to see what you're doing. See you in the next video. Bye.